Unfortunately, I don't know any Italian, so probably some of the stuff I would be talking about I've heard already during Luigi's talk. So, but anyway, please make this presentation as interactive as possible. Please just ask questions as I will be going, and please participate. So, what I'll do a quick introduction into AnyLogic and applications of simulation modeling. We're a little bit of focus on supply chains, logistics, but we will also do some other stuff. I'll try to do some live demos as well, so not just PowerPoint slides, but also some running simulation models. Instead of talking about our company history, etc., I just decided to show you some of our clients. So as you can see from this slide, our client base is very diverse, and you can find here companies doing logistics, supply chains, consulting companies, pharmaceuticals, defense, all sort of stuff. Some of the rectangles here are blank. This is because we're not allowed to display the logos, but no one prevents me from telling you who they are. So probably I'll tell about a couple of them. So this is General Electric, our oldest and probably biggest user so far. And GE is doing a lot of work with AnyLogic as kind of almost corporate standard for simulation there, starting from supply chains for aircraft engine parts to healthcare applications. This rectangle is Rolls-Royce, a very similar application. You know that Rolls-Royce is not only doing cars, making cars, but also doing aircraft engine, which is their main business, by the way. And same thing, managing maintenance of aircraft engines and supply chains for aircraft parts. Aircraft engine parts. So horizontal product, very diverse clients. This is what AnyLogic currently is. We have 3 offices. Well, historically we started over here in St. Petersburg. Now we have an office in St. Petersburg, Russia. This office is rapidly growing. Next year we'll have 8 people working there. And we also have a very small office in Paris, France, mainly serving French customers. And we also have a set of distributors worldwide. 2 of them are present here, you know, of course, Fair Dynamics, and also Dave from DSC Consulting is here, and he will be presenting later on. So this is our geography. Now, I know you have seen this slide already, so I'll make no comments, just go through this slide quickly. So, out of all possible types of models that people do to solve problems, we're concentrating on dynamic simulation modeling. So, whenever the system is dynamic, time is important. Time, causality. Then simulation modeling makes a lot of sense and may give you a better insight into what's going on in the system. Now, imagine you're a big company. So where in a big company simulation is being used? Let's say you're selling and you have a market. So like market research analyst may use some tools like Excel, statistical tool like SAS, and also some simulation tool X to do the market analysis and forecasting. If the company has a manufacturing part, there for sure are some industrial engineers who concentrate on reducing cost and optimizing throughput, etc. And they may use some other simulation tools. If a supply chain is a significant part of the business, then there are supply chain analysts who work on inventory policies, transportation costs, network structure, supplier choice, etc. Well, this may apply to companies who have R&D projects like pharmaceuticals or similar, and then they have a task of optimizing the portfolio of projects and products. So some simulation may go on there as well. The current situation is that all these people are people from different departments using different tools, not constantly. Some tools are just bought for the purpose of doing one project, then the tool is just basically thrown away, and then some other people come in and they need to learn, maybe to purchase another tool, to learn the tool, etc. And so all this simulation work is pretty much done in isolation, one department from the other. And what is also important, that a large amount of data that these days are accumulated in the companies pretty much remains unused. Why is this happening? Is this because different problems that are best addressed with simulation require different methodologies. And this is, as far as I guessed, is something what Luigi has already talked about. So for strategic market analysis, system dynamics is being used. For manufacturing or factory floor process planning, you would use discrete-event simulation, process-based modeling. Probably same for supply chain. Although you know that these days supply chains are best modeled using agent-based methodology. Well, for project portfolio, people do use agent-based modeling a lot already. The traditional tools that are on the market, I know there are many of them, they tend to just support one particular modeling methodology, and what we call force the modeler, the analyst, to think in terms of particular language, particular set of primitives, which is already a limitation. But also there are problems, and specifically supply chain problems, that do not really completely conform with one particular modeling paradigms. They may require a combination of modeling approaches. So basically what we do with AnyLogic, we take all three major modeling paradigms, combine them within one platform, one tool, and allow modelers to efficiently change the level of abstraction, to change the methodology and combine them within one model. So basically, AnyLogic is the leader in flexibility and scalability. As your needs for simulation grow, AnyLogic will always grow with you. So this is kind of the main idea behind the software. So benefits of using AnyLogic are these. First of all, well, AnyLogic is a multi-method simulation modeling software, and also it runs everywhere on any kind of platform, Mac, Windows, Linux, etc. It integrates with any kind of data sources and other softwares like databases, text files, Excel spreadsheets, etc. With ERP systems, CRM systems, etc. So it's very open tool, and you can build AnyLogic models into bigger application and vice versa. And finally, it allows for networking between simulation experts in your company, because they can share expertise, they can share They can even share licenses because you have a project in like supply chains this year. You use AnyLogic licenses there. Next year you have a project in a different part of the company. Still use the same expertise, same license, and you can even integrate models. I'm about to show you some models now, and the first couple of examples will be just simple single method models. So let's say in a company have a manufacturing part of the company. Typically, the manufacturing part of the company would be modeled using Discrete-Event or process-based methodology. So you have your process flow chart, you have entities and resources. Same thing applies to warehouse models or like business process models. So Discrete-Event is one of the oldest modeling paradigms that is used for problems like the ones shown on this slide. So I'll do a quick demo. In the model I'll show, the market will not be represented by system dynamics at the system dynamics level, but it will be represented by individuals, people who are your clients, or maybe businesses who are your clients. Each person will have its own location, so we will take geography into account, and will have its own like purchase behavior. So inside each person will have what we call a state chart. For example, this guy is potential user, is not using our product. Then, okay, he's convinced, he wants to buy. If the product is available, he buys. Then after a while, when the product gets old, discards, he goes back here, waits for another product, if he needs to wait because of the availability, etc. So each person, each consumer will be represented as an agent in such a model. So things like individual parameters, location, age, usage patterns, purchase behavior, also income, education can be taken into account in such models. So the big data these days is a very hot topic. Every big company is talking about the big data. And essentially, what is big data? Big data is great amount of information that you can now collect, and you have physical ability to store and to search, right? So with big data becoming available, agent-based models will progress. I mean, the amount of agent-based modeling done in the world will be multiplied, because this is where your big data can go into to parameterize your for example, clients in your customers in the models like that. So a demo. I'll show you, and this is a proof of concept supply chain model. So you can consider it as a let's say abstract supply chain, which demonstrates the technology. So what we have here, we have a nationwide supply chain with 1, 2, 3 suppliers of whatever is raw material here. We have 2 factories, and each factory is producing, well, they're both producing the same products using parts from these 3 suppliers. The The yellow guys are distribution centers. And there are quite a few of them. And the green guys are retailers. So this is, at the top level, this is an agent-based model. Each object I'm clicking on has some behavior inside, has some parameters, and I can actually tune the parameters manually by using these sliders. For example, this is a factory. So we have like production, the capacity of the factory, this top level slider. I have the inventory, I have as small as capital S inventory policy here, and the parameters of the inventory policy can be changed using these two sliders, and also some vehicle fleet size. Okay, so I can view this supply chain in 2D and 3D. These bars here are the amount of inventory, and this red bars going downwards are the order backlogs at, for example, at this factory. So, but also what? Sorry, this is Windows 8. What is probably more important, that we have consumers here, and if I tick this box, show consumers, we will see a lot of small green dots. So each green dot here is an object in the model, and each object has its own purchase behavior. So in this case, we have 150,000 consumers in this model. So in addition to probably 100 of supply chain objects, we have another 150,000 objects representing consumers. And they may represent individual consumers, if you have that many of them. But let's say if we're selling to the population of the United States, these dots can represent groups of consumers with similar behavior. And basically this, let's say, technology has been used recently to model North American automobile market and the project was done by General Motors company. So just to demonstrate you how the models like that work, what I'll do something bad to this producer. Like I'll reduce the production capacity, and I'll do something wrong with the inventory policy, and also I'll reduce the vehicle fleet size. So you see that the order backlog grows, and probably I missed a little bit the moment when there was a shortage of the product, and the consumers were turning red. So, yeah, okay. So you see there were periods when the product is not available, and and you probably can see that the structure, I don't know how much you can see on the screen, but the structure of the supply chain is changing because the objects are adapting to the situation where one factory cannot really produce enough product, and the supply chain is trying to compensate this through reconfiguring itself. So if I do something wrong, let's say to this warehouse as well, sorry, this distribution center. And yeah, so, and to this one, because right now the supply chain is still fighting the problem, and see. Just continuing destroying the supply chain here. Yeah. Okay, so finally, we see that the backlogs are growing, and the consumers are getting unsatisfied, and probably in the real situation they will switch to a competitor's product. Okay, so that was a let's say abstract supply chain where we have combined modeling of the manufacturing, distribution, retailers, supply chain policies, and supplier choice, and the model of consumers. Just a very very simplistic demo I have here. So just close all the windows. This is a implementation. This is the model of a project. Research, development, project or products, and in markets. So this is basically a project, and this is already a product, which is in market. This is a state chart, one of the greatest languages to describe behavior of agents in agent-based modeling. And I run this model. So every dot in this chart is a project turning into a product. So research phase, development phase, and in-market. And the investment policy is being modeled by a system dynamics stock and flow diagram. So if I run this a little bit faster, so you see that some project getting killed. And okay, I'll pause it. And okay, for example, this project is already in the in-market phase. Okay, so okay, this project number 34 is in the research phase, etc. I'll go back to this main view, and the bigger is the size of the bubble here. The bigger is the revenue the product is currently bringing to the company, and the part of the revenue goes into R&D, and this fraction of the revenue is controlled by this max fraction parameter. Of course, this is a very simple model, but still I can do some experiments here. For example, right now, at most 20% of the company revenue goes into R&D. So what if I make it 7%? See that after a while, the company just ceases to exist because in not investing enough into new technologies. So, of course, this is a simple proof of concept thing, but this gives you some idea of how else can you use agent-based modeling in business applications. Okay, so Luigi, how much time do I have?
Yeah, we should finish.
Yeah, I should finish.
5 minutes.
5 minutes. Okay, good. So we did that. Yeah, I only have a few slides left, actually. So some just concluding words about AnyLogic. So what we have in AnyLogic, at the bottom level, this is Java. Everything we do is based on Java. And you know that Java has advantage of being cross-platform. So that explains our choice. Now we have the visual language level. You saw the process flow chart with delays and queues. This is one of the visual languages that we support. You saw the system dynamics stock and flow diagram, like the one in the project portfolio model. And finally, we have agent-based with state charts. Now, the next level is domain-specific libraries. And AnyLogic supports some verticals in particular, like, for example, pedestrian model. I haven't shown any models because of lack of time, but we have a pedestrian library. We have some support in healthcare. We have support for rail modeling, in particular for rail yards, and for supply chains and logistics. So on top of that, you develop your models, and you can directly use either higher level primitives or these core visual languages, or if you want, and if you know how to do it, you can use Java. On top of that, you have various experiments: optimization, calibration, Monte Carlo, sensitivity analysis, etc. So this is how your, let's say, simulation application is structured. AnyLogic works with various, let's say, supplementing technologies. Optech is an American company. Their product is OptQuest. It is integrated into AnyLogic. It comes with a tool. It allows you to search for optimal parameter sets in your simulation models. StatFis is distribution fitting software as well as expert fit. You can read and write data from text. Well, XML is another text format. Excel, Access, or other generic database through JDBC. And AnyLogic specifically supports connectivity to databases, so you don't actually have to write code. You can import CAD drawings, like factory floors, for example. You can use GIS maps if you want, for example, your supply chain be visualized over the GIS map space. And also 3D models of external 3D objects. And also you can integrate with CRM, ERP, other programs, etc., etc. I will not be doing OptQuest demo. This slide just shows that we're cross-platform. So you can develop models in Windows, Mac, and Linux, but you can run models also on these three platforms, plus you can run models in a browser as applets. And actually, this is the way you can share models with others. Just publish a model as an applet and let your colleague or even client to run it without installing the software. And finally, I would like to show you the site, runthemodel.com, and this is the online collection of AnyLogic simulation models. So even if you don't have AnyLogic installed on your computer, you can go here and search for something like airport. And then you will see like how many, 5 airport models on this runthemodel.com website. And well, these are the models, only I think this one was uploaded, these 2 were uploaded by us. Other models were uploaded by somebody else. And you can just click on the model, see the description, and run the model in your browser. So while this model is loading, I would like you to ask some questions. And whatever you want, and what else you want to know about AnyLogic or technology, business applications of simulation modeling, please go ahead with your questions. Yes?
Well, in the second model you showed to us there were some vehicles that moving around some shelves.
Yes.
And which is the algorithm that moved those vehicles, if there is one? Maybe they take the shortest path between 2 points, or they...
Right. So a part of AnyLogic is what we call network and routing algorithms. So you don't have to develop them yourself. AnyLogic will put together a network and do all the routing tables for you. So all you need to do is just where it is. So all you need to do is
can
just
see and modify those algorithms. Or?
You can you have programmatic access, I think, to the routing tables.
Okay.
So if you want, you can. Otherwise, but this is done kind of rarely. So all these spaces kind of marked up with nodes and paths, and when the model is run, it basically uses the predefined routing here, right? So all you do is you say, okay, this forklift truck moves from here, from the bay to this like sorting area, whatever, and you don't care about how it's implemented. If you want, you can affect this.
Okay.
Mm-hmm. Okay. Other more questions, please?
Anyway, we have another question and answer time at the end of the presentation. So thank you very much, Andrei, for your very focused and clear presentation. And we just a clap.
Thank you.